All right, so question number 3 find all the solutions of the equation 2 times cos of 2x plus 2 of cos x equals 0 in the interval 0 to 2 pi. All right, so we're going to need to use some trigonometric identities, and namely we're going to use the cosine double angle identity. So the cosine double angle identity states that the cosine of 2x is equal to 2 times the cosine squared of x minus 1. And if you want to find this proof, you can just search up double angle identity proofs and you'll find the proof for this. Okay, so we're going to use this trigonometric identity to solve our, to find the solutions to our equation. And before I continue, they're basically asking us to find the values of x that will satisfy this equation in the interval of 0 and 2 pi. All right, and these are what we call radians, and these are equivalent to what we have as degrees, since we're dealing with cosine functions, because trigonometric functions use radians or degrees as its independent variable, okay? So that's another thing that we need to keep in mind, okay? So we need to find the values of x that will satisfy this equation. So first, let's rewrite our equation here. So 2 times cosine of 2x plus 2 of cos x equals to 0. Okay, the first thing that we're going to do is to apply our trigonometric identity. So that's going to be 2 times 2 cos squared of x minus 1 plus 2 cos of x equals to 0. Okay, if we were to expand this now, we would get 4 cosine squared x plus 2 cos x minus 2 equals 0. Alright, so does this resemble anything that we have seen before? And the answer is yes, right? So this is a quadratic function, but instead of having our independent variable of x, we have the cosine functions as our independent variable here. Okay, so in all actuality, we can use a quadratic formula, or we can factor it to find the factors. And if we find the factors, then we can find the zeros or the solutions to this quadratic equation. Okay, so first we're going to simplify this because we can divide the left-hand side and the right-hand side by 2. So if we do that, we get 2 cosine squared x plus cos x minus 1 equals 0. So now we're going to use my cross multiplication method. So we're going to state the coefficients of our leading term and our last term, and we're going to cross multiply them and add them together to see if we get our middle term here, which is the coefficient of 1. Okay, so the factors of the coefficient of our leading term is 2 and 1, so we're just going to use 2 and 1. And since the coefficients of c is negative 1, then the factors has to include a negative number, so we're going to say negative 1 and 1. So let's check to make sure. So 2 times 1 equals to 2, and negative 1 times 1 is negative 1. So we have our correct factors. So now if we were to cross multiply this together, we would get negative 2, or 2 minus 1, and we get 1, which is equal to the coefficient of cos x, right? The coefficient of our middle term b is 1, right? So now that we have found this, we can write out our factors, which is 2 cos x, right? Make sure that you include your variable here, which is cos of x minus 1 times cos of x plus 1. Right? Equal to 0. Now we have to remember our special angles, right? We have to remember what angles or what radians make this to equal to 0. Okay, so we need to find when this equals to 0 and when this equals to 0. So when 2 cos x equals to 0, minus 1 is equal to 0, and when cos of x plus 1 is equal to 0. Okay, so we're going to isolate for cos x here, and if we isolate, we get 1 over 2. And for the second one, we get cos of x equals negative 1. Okay, so what are our special angles for cos of x equals half? Well, so if we know our special angles, I won't get into too much details about the special angles here, but we have pi over 3, we have pi over 4, and we have pi over 6, okay? So we know that cos of x equals 1 near at cos of 0. So we're going to say that cos of x equals half when x equals pi over 3. Okay, because root 3 over 2 is greater than half. Okay, and cos of x equals -1 when x equals pi, right? So when x equals 2 pi or 0, we have cos of x equals to 1, right? So cos of x equals -1 when x equals pi. So now we have found our solutions, right? But we have to be worried about the interval here, right? The interval is from 0 to 2 pi, right? So cos x equals half at pi over 3 and also 5 pi over 3. So we have to include that in our answer here. So therefore, 2 cos of 2x plus 2 cos of x equals 0 when x equals pi over 3, 5 pi over 3, and pi. Okay, and I don't really want to get into too much about the special angles, but you guys can search it up on the internet, and you guys can confirm when cos x is equal to half and when cos x is equal to -1, interval of 0 to 2 pi. Okay, so other than that, the solution is correct. Okay.